In this lesson, we're going to look at AMU2L5, and we're going to be talking about the average rate of change. So first, let's just review regular slope. All right, your formula for slope, if you remember, slope is rise over run. It is also equal to y2 minus y1 over x2 minus x1, where x and y are the coordinates of any point on your graph. So let's just look at number 1 first. I want to kind of dig a little bit deeper in this. Let's label the points. We're going to call this top one A, this one is B, and then we're going to create one more point down here at C. We're not going to do this for every one. I just want to remind you of some things about slope. Primarily that slope is constant all the way up and down the line, no matter how far apart you are. So first, I want you to find the slope, and we're just going to count up and over, rise, run, from A to B. So if we start at A, how much do we rise? Well, we actually go down 1, 2, 3. So that's -3 over, and then what we're going to run to the left, 1, 2, 3, 4. So the slope would be +3/4. Now I want you to find the slope between the points A and C. So we're going to rise from A, 1, 2, 3, 4, 5, 6. So that's -6. And then we're going to run 1, 2, 3, 4, 5, 6, 7, 8, -8. Now if you simplify that, you get 3/4. See, it didn't matter if you were going from A to B or A to C, the slope was the same. So now I want you to look at the slope backwards from B to A. So if we start at B and I go rise, 1, 2, 3, and then I run 1, 2, 3, 4, you see you still get 3/4 slope. So it doesn't matter whether you go left to right, right to left, as long as you're consistent, and it doesn't matter which 2 points you pick. You will always get the same slope. All right, let's go to number 2. This time we're just going to find the slope between the 2 points they give us. So if I'm looking for rise over run, I'm going to start down here at this point, and I'm going to say I'm rising 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to run 1, 2, 3, 4. So that is backwards. That's -4. So my slope here is -2. Okay. And then on this third one, and I know this is just a review, so you should be very familiar with this. From one point to the next, do you rise at all? No. Your run is 8 if you want to put it that way. So your slope is 0. Okay. Now number 4, on these next 3, we're given 3 points. So we're just going to use the slope formula. M is equal to y2 minus y1 over x2 minus x1. Now it does not matter which pair you let be pair number 1 and pair number 2. Like I just showed you, slope is constant, but you do have to be constant. You have to be consistent. So what I always do is I label my points 1 and 2 and then x and y. This just makes it easier for me to, I don't have to think so much while I'm filling in. All right, so I want y from pair number 2, which is -7, minus the y from pair number 1, which is 3, over the x from pair number 2, which is -5, minus the x from pair number 1, which is -9. All right, a little bit of simplifying here gives us -10 over +4. Reduce that down, and your slope is -5/2. All right, let's go to number 5, and once again, I'm going to label my points so that I don't get confused. And now on to slope. I want the y from pair number 2, which is -4, minus the y from pair number 1, which is -1, over the x from pair number 2, which is -7, minus the x from pair number 1, which is +2. So -4 plus 1 is -3. -7 minus 2 is negative 9. And negative over negative is positive. 3 over 9 reduces down to 1/3. And number 6, once again, here's pair 1 and pair 2, xy, xy. So the y from pair number 2 minus the y from pair number 1 over the x from pair number 2 minus the x from pair number 1. All right, 3 minus negative 5 is 3 plus 5, so that's 8. 1 minus negative 13 is 1 plus 13, negative 1 plus 13, so that is 12. And it reduces down to a slope of 2/3. Now let's look at slope that may be a little bit different. This is called average rate of change. What we just found was the slope of a linear function. It's a straight line, and that slope is constant between each pair of points. But for nonlinear functions, like your parabola that's pictured below, the slope changes between different pairs of points. So because of this, we find what we call the average rate of change. The average rate of change of a function between 2 points is the slope of the line that passes through these 2 points. So what we're doing, here's a line that goes through 2 points. We're going to find that slope. All right, the line is called a secant line. And we have a formula. The formula for the average rate of change is, and this is slope, and we're going to subnotate it as secant. So the slope of the secant line is equal to f of b minus f of a over b minus a. Okay. And we will look at some examples. Your f of b and your f of a are naturally going to be the function. Now, you're going to have an interval, a to b. So that's what we're looking for. These 2 points would be your interval. Here's a and here's b. Okay, let's look at number 7. We want to find the average rate of change on each interval. And here's your interval. This interval corresponds to a and b in the formula up above. So that takes care of b minus a. But what about f of a? Well, if a is negative 2, I'm going to come over here to my graph and I'm going to find the x at negative 2, and then I'm going to look up to find my y. So where is that point of intersection? And that point of intersection is at positive 1. All right, next I need to find f of b. Same thing. If my b is 1, I'm going to come over here to my graph and I'm going to go to the 1 on the x-axis, and then I'm going to find the point of intersection, and it is all the way down here at 1, 2, 3, 4, 5, 6, 7, 8 at negative 8. So f of b is negative 8. Now you have everything you need to fill into your formula. So we're going to say, okay, the slope of the secant is f of b, which was negative 8, minus f of a, which was 1, over b, which was 1, minus a, which was negative 2. Right, negative 8 minus 1 is negative 9. 1 minus negative 2, it changes to plus a positive, so you have 3. So your slope here is negative 3. Now let's look at number 8. We're using the same graph. So this is A, this is B. Now if I want to find f of A, I'm going to come over here to where 0 is, and I'm going to go down until I find the point of intersection. And the intersection is at 1, 2, 3, 4, 5, 6, 7. So f of A is negative 7. Okay, f of b, well, if b is at 4, I'm going to go over to 4 on the x-axis, 1, 2, 3, 4, and I'm going to find the point of intersection, and that point of intersection is up at positive 1. And now I'm ready to fill into my formula. So, the slope of the secant is f of b, which was 1, minus f of a, which was negative 7, over b, which was 4, minus a, which was 0. Simplifying gives us 1 plus 7 is 8. 4 minus 0 is 4. So my slope is positive 2. Okay, now we're on the next page, and you might want to write your formula up at the top here. The slope of the secant is equal to f of b minus f of a over b minus a. That's what all this is going to revolve around. So, first, and you may want to do some of this work on scratch paper because I'm going to use the whole box because I do a lot of work. Okay, first I have A and B. Now I need to find f of A and f of B. So, f of A is f of negative 1. So I'm going to fill that into this quadratic equation up here. I'm going to have negative of negative 1 squared plus 6 times negative 1 minus 14. And negative 1 squared is going to be positive 1. So then I have another negative out there. So that'll be negative 1. 6 times negative 1 is minus 6. And minus 14 is going to give me negative 21. All right, that is f of A. Now let's find f of B. Well, B is 2, so I need to find f of 2, and I'm going to plug it in. Negative 2 squared plus 6 times 2 minus 14. All right, 2 squared is 4, so this is negative 4 plus 6 times 2 is 12 minus 14 is negative 6. Now we have all the components, so we just need to plug them into our formula. The slope of the secant is, all right, f of b, which was negative 6, minus f of a, which was negative 21, over b, which was 2, minus a, which was negative 1. And negative 6 minus a negative 21 is 6 plus 21, so that's 15. And 2 minus negative 1 is 2 plus 1, so that's 3. So your slope is 5. Okay, let's move on to number 10. And once again, this is A and this is B. So the first thing I need to do is find f of A, which means f of negative 9. So I'm going to fill that into my equation up here. So I've got 2 times negative 9 squared plus 28 times negative 9 plus 93. So this is going to be 162 plus negative 252 plus 93. And when you combine all those, you get positive 3. Now to find f of b. All right, b is negative 7, so I want to find f of negative 7. I'm going to plug that in. So I have 2 times negative 7 squared plus 28 times negative 7 plus 93. So that's going to give me 98 plus negative 196 plus 93. Combining all those gives me negative 5. Now I'm ready to fill in. So the slope of my secant is equal to f of b, which was negative 5, minus f of a, which was 3, over b, which was negative 7, minus a, which is negative 9. Negative 5 minus 3 is negative 8. Negative 7 plus 9 is 2. And when this simplifies out to negative 4, that is your slope. Let's move to number 11. And I'm going to label A and B. So the first thing I've got to do is find f of A, which means find f of 4. So I'm going to plug it in. This is 4 to the third power minus 2 times 4 to the second power minus 9 times 4 plus 1. All All right, 4 to the third power is 64. This will be minus 32, minus 36, plus 1, and all that combines to give you negative 3. So there's f of a. All right, now let's find f of b, which means find f of 7. So we're going to fill that in. I've got 7 to the third power minus 2 times 7 to the second power minus 9 times 7 plus 1. And this will equal 343 minus 98 minus 63 plus 1. Those will all combine to give us 183. And now we're ready to find the slope of the secant, or the average rate of change. So we're going to put f of b, which was 183, minus f of a, which was negative 3, over b, which was 7, minus a, which was 4. All right, minus the negative changes to plus a positive, so 183 plus 3 is 186, and 7 minus 4 is 3. 186 divided by 3 is 62. Okay, number 12, label A and B. First, let's find f of A, which means finds f of negative 2. So we're going to fill in carefully. Negative 2 to the fourth plus, this will be 3 times negative 2 squared minus 17. All right, negative 2 to the fourth is going to be positive 16, and then that negative there in the front makes it negative, plus negative 2 squared would be 4, and 3 times 4 is 12, minus 17. Those will combine to give you negative 21 for f of a. Now let's find f of b, which means find f of 5. So when I fill this in, I have negative of 5 to the fourth power plus 3 times 5 to the second power minus 17. All right, negative 5 to the fourth power is 625 plus 5 squared is 25 times 3 is 75 minus 17. Those all combine to give you negative 567. We're ready to find the slope of the secant. So m sec is equal to negative 567, that's f of b, minus f of a, which was negative 21, all over b, which was 5, minus negative 2, which was a. All right, combining terms, this will give you negative 546 over 7, and that will divide out to be negative 78. Number 13, let's label A and B, our points up here, and then we're going to find f of a, which means find f of 2. So I'm going to plug in 2 for the x, so this is 2 minus 4 over 2, which gives you negative 2 over 2, so that's negative 1. And there's your f of a. All right, f of b is equal to, we're going to fill in the 8. So now that's going to give you 8 minus 4 in the numerator over 8 in the denominator, and 4 over 8 is equal to 1/2. So let's fill into m sec, and this is going to be, all right, f of b was 1/2 minus negative 1 over 8 minus 2. All right, this gives us 3/2 over 6. Now remember, when you divide fractions, you can make the bottom one into a fraction, and then you're going to keep change flip or multiply by the reciprocal. So you wind up with 3/2 times 1/6, which reduces down to 1/4. Okay, number 14. Here's A and B. So first let's find f of A, which means find f of -1. So that is going to be the square root of -1 plus 5, which is the square root of 4, which reduces down to 2. All right, then we're going to find f of B. All right, that means f of 7. So I'm going to put set square root of 7 plus 5, which is the square root of 12. And you should remember that that will reduce or simplify out to be 2 square root of 3. Okay. Now, plugging all this into MSEC. So I want f of B, which was 2 square root of 3, minus f of A, which was 2, all over B, which was 7, minus A, which was -1. So I have 2 square root of 3 minus 2 over 8. Now that's fine, but it's not in simplest terms. We need to simplify this. A fraction, and this is a fraction, is never in lowest terms as long as there's any number that will go into both the numerator and the denominator. And if you see, you've got these 2's there. 2 will go into 8 as well. So the easiest way to do this, factor that numerator, take your greatest common factor out, and that is going to give you 2 times the square root of 3 minus 1 over 8. Now, 2 and 8 will reduce down. 2 goes into 8 4 times. So your lowest term answer here is square root of 3 minus 1 over 4. Our next two problems are application problems, so let's have a look at this. Number 15 says a company's total cost, C of X in dollars, to manufacture X units is given by the quadratic equation there. Find the average rate of change of the total cost for the first 200 units manufactured. So what is our interval here? Well, your interval is from 0 to 200. So this is A, this is B. Now we're just going to go ahead like we've been doing. All right, to find f of A, I want to find f of 0. When I plug 0 into that quadratic expression up there, I've got 0.05 times 0 squared plus 40 times 0 plus 1200. So that's going to give us 1200 for f of A. Now for f of B, that's going to be f of 200. So I'm going to plug 200 in. So I've got 0.05 times 200 squared plus 40 times 200 plus 1200. So this is going to give us 2,000 plus 8,000 plus 1,200, and that's going to equal 11,200. So here's our f of B. All right, now our MSEC is going to be f of B, which is 11,200, minus f of A, which is 1,200, over B, which was 200, minus 0. So that is going to simplify down to 10,000 over 200, and that will equal 50, and this answer will be in dollars per unit. Now for number 16, a ball is thrown straight upward so that its height, ht, in feet, is given by the equation ht is equal to -16t squared plus 80t, and t is your time in seconds. So we want to find the average rate of change in the height of the ball from when it reaches its maximum height until when it reaches the ground. So what we have here is a situation The ball was thrown up and then the ball came down. We want to find the average rate of change between its apex and hitting the ground again. And you're going to have to do some recalling of some of your quadratic equation knowledge. How do you find the vertex? Well, there was a formula that we learned back in Algebra 2 that told you the vertex was equal to negative b over 2a. So let's find that first. What is b and what is a? Well, here is b. Remember, b is the coefficient of your linear term, and a is the coefficient of your quadratic term. So if I fill that in, I have negative 80 over 2 times a, which was negative 16. So that's going to give me 80 over 32, which is 2.5. All right. So that's the first part of my interval. That's where it's up here at the top. Okay. So now to find where it hits the ground, which is this part down here, you're going to take your quadratic equation up here and you're going to put 0 equals negative 16t squared plus 80t. Because 0, the height at 0, that's where it's hitting the ground. Okay, so when we solve this quadratic equation, I'm going to do it by factoring. So you get 0 is equal to, all right, negative 16t is your common factor. So we're going to factor that out, and that will give us t minus 5. And then we're going to use the zero product property. So we're going to have 0 is equal to negative 16t, which means t is equal to 0, or t minus 5 is equal to 0, therefore t is equal to 5. So I have options here, either at 0 seconds or at 5 seconds. Well, 0 seconds has already passed. That's where it took off, and I'm not worried about that. I'm worried about this side of it. So I want the 5. That becomes the other part of my interval. Now, what we have to do, here's A and here's B, we have to do just what we did with all the other problems, and I don't have a whole lot of room. So, you're going to take A and plug it into here, and that's going to give you f of A, and I can go ahead and do all the math for you. When you take this number and you plug it into this expression, you will get 100. If I do the same thing with B, with 5, if I plug 5 in to this expression, that is going to give me 0, believe it or not. So now I'm ready to plug into MSEC. All right, when I plug into MSEC, I want f of B, which was 0, minus f of A, which was 100, over B, which was 5, minus A, which was 2.5. And then you can do all the simplification and all the math, and that will get you negative 40, okay? And this is in feet per second.